Good morning everyone. Welcome to A2z Physics and Chemistry class. Today we are going to discuss about very important part of class 12 physics, that is cell internal energy and electromotive force. Okay, cell internal energy and electromotive force. Okay, we know a simple device which is used to maintain the steady flow of current in an electrical circuit is called electrolytic cell. That means an electrolytic cell is used to maintain the steady flow of current in an electrical circuit. An electrolytic cell mainly consists of two electrodes. Okay, that is the positive electrode and the negative electrodes, which are dipped in a electrolytic solution. Okay. Now the potential of the positive electrode with respect to the electrolytic solution is taken to be V plus, and the potential of the negative electrode with respect to the electrolytic solution is taken to be, this is minus V minus. Okay, so the potential difference between these two terminals of the electrodes will be equal to, this is V plus minus of minus V minus, which is called as your V or potential difference. So we can say this is V equal to V plus plus V minus, but here this is represented as E, or we can say this is electromotive force. Okay, so now again repeating the same thing. As we know, the electrolytic cell mainly consists of the electrode which are dipped into the solution of the electrolytic solution. Now the potential of the positive electrode is V plus with respect to the electrolytic solution, and for the negative electrode, this is minus V minus with respect to the electrolytic solution. Now this is V plus minus of minus V minus, which is called as the potential difference between the two electrode, which we can say this is the electromotive force. Okay. Now to understand what is the significance of the electromotive force, let us insert a resistor in between the two electrodes. This is the resistor which we have connected in between the two electrodes. Okay, and the electrolytic solution also offers very small resistance, which is called as the internal resistance. This small r is called as the internal resistance. Internal resistance, which is offered by the electrolytic solution. Now, okay, to understand the significance of the electromotive force, we have to discuss, or we have to insert a resistance in between the two electrodes. Electromotive force is not a force. Okay, so it is actually a potential difference. This is the important one. This is a potential difference. It is not a force. Okay, this E represents the electromotive force, which is not a force, but it is a potential difference between the two electrodes. Okay, now as we know, already we have discussed that the potential, if we want suppose to know the significance of the electromotive force, we have inserted here a resistance capital R. As we know, I equal to V by R. From Ohm's law, we know I will be equal to V by R. So when R equal to infinity, okay, when the value of the R is infinite, at that time what happens? I will be equal to V by R, and this value will be equal to 0, because in this case R is infinite. That means this is open circuited. Now the potential difference is termed as, this is IE. As we know, from Ohm's law, I equal to V by R. So when R is infinite, at that time the current flowing through the circuit will be equal to 0. So the potential difference now which exists between the two electrodes is called as the electromotive force. But when the resistance is finite, at that time what happens? We know the potential will be equal to, this is V plus V minus, there is a minus IR. Okay, that is minus IR. So this here the IR value, here there is a negative sign of the current, because in this case there is a flow of the current from the B electrode to the A electrode. So there is a negative sign over here. Now again we know that from the definition, this V plus V minus represents the electromotive force, Now this is I into R. Okay. Now from Ohm's law, again this V represents IR and this will be equal to E minus IR. Okay. Now this E will be equal to IR plus IR. Taking I common, this is R plus R, which will be equal to E. Or this I will be equal to E R. So here we have got I equal to E by R plus R. So there will be maximum current when the value of R will be equal to 0. Then I will be equal to E by R, and there is a maximum flow of the current in the circuit. What is maximum? The maximum current will damage to the electrolytic cell. So normally the I maximum will be less than as we are finding or as we are calculating by this formula. Okay. So this is all about the cell, internal energy and EMF. Next we have to switch over to the combination of cell, which is cell in series and cell in parallel. Just like the resistors are connected in the parallel and the series combination, so also the cell are also connected in series and parallel combination. So the cell in series. So cell in series. So in this case, okay, so here two cells are connected and they are in the series connection, and we have to find out what is the analysis in this cell in series connection. Okay, so first this is VAB will be equal to VAB represents the potential across A and B terminal, which is VA minus VB. Okay, so this is now according to as there is a electromotive force E1 over here. So this is E1 minus IR1. Okay, in this case this is E1 minus IR1. As we know from the formula, the potential V will be equal to E minus IR. So here VAB will be equal to E1 minus IR1. Similarly, the formula for VBC, this is VB minus VC, which will be equal to E2 minus IR2. Okay, now combining these two equations, VAC will be equal to VAB plus, and this is VAB will be equal to, we can say this is VAC will be equal to VA minus VC. So now this is E1 minus IR1. Again next this is plus E2 into or E2 minus IR2. So this will be equal to now E1 plus E2 minus I common. This is R1 plus R2. Okay. Now in series combination, here the VAC will be equal to, which is E equivalent minus I R equivalent. Okay. So in series combination, the net potential across A and C will be equal to E equivalent minus this I R equivalent. So this is about the cell in series connection. Next we will switch over to cell in parallel connection. Cell in parallel connection. Okay. So now we have to connect a cell this is about the cell in parallel connection. That means this here, this cell 1 and 2 both are connected to the same potential. Let us consider this is V1 and this is V2. Okay. Now, as we know, in parallel combination, the net current will be equal to always I1 plus I2. Okay. So for finding out the I, now first we have to calculate I1 and I2. Now V1 V2 will be equal to V1 minus V2 V1 V2 will be equal to here E1 minus I1 R1. Similarly, this is across the cell 1. Now similarly, across the cell 2, this is E2 minus this is I2 R2. Okay. Now this we can write down the net potential will be equal to, now this is V1 V2 which will be equal to E1 minus I1 R1, and V2 again this is for the E2 minus I2 R2. Now putting this value we can write down this is, or we can say this is V equal to E1 I1 R1, and V will be equal to, as the both of the potential is same over here in the parallel connection, so this is I2 R2. Okay. Now from these two equations, actually we can find out the value for I1 and R1. That is here, if we take the I1 R1 value to the left hand side, then this I1 R1 will be equal to E1 minus V, and this I2 or this I2 R2 will be equal to E2 minus V. Then I1 will be equal to E1 minus V by R1, and I2 will be equal to E2 minus V by R2. So now this is E1 minus V by R1 plus E2 minus V by R2. Okay. Now this is E1 minus by R1 plus E2 by R2. Then this is E1 by R1 plus E2 by R2. Then taking V common, this is 1 by R1 plus 1 by R2. Okay. Now, as we know this, now from this equation we can calculate the value of V, and that value will be equal to, now here V will be equal to E1 R by R1 plus E2 by R2 minus I into R1 R2, or we can say here, if we can directly write over here, this is E1, this is R1 R2, E1 R2 minus E2 R1, and this is V R1 R2 by R1 plus R2. Then we can say this V value will be equal to E1 R2 plus E2 R1 by R1 R2 minus I R1 R2 by R1 plus R2. Okay. Now this value will be equal to, again sorry, in this case we have to put down over here, this is R1 plus R2. Okay. So now we have got the value V for this. Okay. Now this V value will be equal to, now E equivalent minus I R equivalent. Okay. So E equivalent value will be equal to here E1 R2 plus E2 R1 by R1 R2, and the R equivalent equal to R1 R2 by R1 plus R2. Again repeating, as in this in parallel connection, the net current will be equal to the summation of the individual current. So I will be equal to I1 plus I2 over here. Now from the diagram, I will be equal to E1 minus V by R1 plus E2 minus V by R2. Now this is E1 by R1 plus E2 by R2 minus V taking common. This is 1 by R1 plus 1 by R2. Now taking LCM, this is R1 R2, E1 R2 plus E2 R1 minus V into R1 R2, and there is R1 plus R2. Now we can calculate. This is the formula for the I. What we have to calculate the V value. So now taking V left hand side and recombining this equation, we got E1 R2 plus E2 R1 divided by R1 R2 minus I R1 R2 by R1 plus R2. So this is V equal to E equivalent minus I R equivalent. Okay. So this cell can be arranged in two ways, either in the series connection and in the parallel connection. So today we have discussed about the cell internal energy, electromotive force, and there is the cell in series and cell in parallel. So today this much. Hope you enjoy my classes. So do subscribe my video. Thanks for watching my video.